Okay, class 10. Now question number 14 of 6.5 says a perpendicular from A on side BC of a triangle ABC intersects BC at D such that BD is 3 times CD. Okay, so this is your figure there that is already given in the question. Okay, so I'm repeating it. It is saying the perpendicular from A on side BC, okay, is intersecting the side BC in such a way such that DB here is 3 times CD. Okay, clear? Okay, then you have to prove whatever that 2 times AB square is equal to 2 times AC square plus BC square. Okay, so what are we observing here? If that perpendicular is there, you have Pythagoras theorem here. We need in the proof, we need AB. So AB square can be observed in this triangle. Then we need AC square, which is in this triangle. Okay, and then we have to talk about the base BC. Okay, so let's see how we go about that proof. Again, we'll squares जैसे ही हमें दिखते हैं Pythagoras theorem strike करता है. Right angle triangle भी है, so we will say we'll apply Pythagoras theorem to wherever we see right angle triangles. So we would say by Pythagoras theorem in triangle ACD, this one or maybe this one first, anyway. So AC square, this is your hypotenuse, AC square is equal to AD square plus DC square. One equation like that. So we can change this as, see, AD is not required in the proof. Okay, AD you see is not required in the proof. So AD, they have made the subject here. We want to eliminate that. Okay, there can be other ways also of elimination. It's up to you. So we've taken DC to the other side. So AD square will become AC square minus DC square. Likewise, the other right angle triangle you had, in that AB square will be equal to AD square plus DC square. Okay, plus BD square, sorry. Okay, so we'll take BD to the other side. So from here also we'll form AD. AD will come as AB square minus DB square, taking this term that side. Okay, so now these two AD squares can be equated. So from these two equations equating, we get AC square minus DC square will come equal to AB square minus DB square. Okay, both of them were AD square each. Okay, so you just now need to put what was given to you. You were given that this relation was given to you. Okay, that DB is 3 times DC. But we don't want DB and DC also in proof. In proof we want BC. So we will write them in terms of BC. Okay, so this will become like, this would be 1 part, this is 3 parts, so total 3 plus 1, 4 parts. The whole of BC will be 4 parts. You get that? Okay, so we will say DC is 1/4 of BC or BC upon 4. Likewise, DB will be 3/4 of BC. Okay, from this given. Can you see that? This whole length BC is sum of DC plus BD. So DC was 1 part, BD was 3 parts. So 3 plus 1 whole BC will be 4 parts. That way, okay? So we will replace these in the above equation, putting those values there. So we get AC square will be copied as it is. In place of DC, you will put DC upon 4. So DC upon 4 whole square will make it, BC upon 4 whole square will make it BC square upon 16. Okay, then AB, this should be square here, children. Okay, square is missing, please correct it. So AB square will be copied as it is. DB will be replaced by 3 BC by 4's whole square. So 3 square is 9, BC square, and 4 square is 16. Clear? Now, what are we doing next is, we have BC. Okay, first LCM. Take LCM throughout. If you take LCM, then this becomes 16 times AC square minus BC square. This also becomes 16 AB square minus 9 BC square. And 16, same denominator on either side has been cancelled. Okay, now what will we do? We will collect all the BC's one side. So we already had 9 BC square here. If you take this, you bring this this side, or maybe you say you take this factor that side. So 9 minus 1 will make it 8 BC squares. Okay, and then what do we have to prove? This is question number 14. So AB square was positive and AC negative. Okay, there's a sign mistake here again, children. This would be 16 AB square minus 16 AC square. So please correct that, okay? So this will become 16 AB square minus 16 AC square. This positive, this negative is equal to minus 1 plus 9, 8 BC square. Cancelling throughout by 8. Cancel this throughout by 8. 8 ones are, so only BC square left here. And here this will become 2 times and this will also become 2 times. So 2 times AB square minus AC square is equal to in the proof you wanted only AB one on the left hand side. So to match up, you can get this AC also to that side. So this will become 2AB square is equal to AC square, 2AC square plus BC square. Okay. Okay, now in the 15th question, what were they asking us to do? Then there was an equilateral triangle ABC and D was a point on BC such that BD is 1/3 of BC. Okay, so this is your equilateral triangle in which D was a point on BC such that BD is 1 part and BC 3 parts. So this remaining would be 2 parts. Anyways, that is not required in the proof. So just jot it down for the time being that BD is 1/3 of the whole BC. Then you had to prove that 9AD square will be equal to 7AB square. So we need to, in the proof, we need AD square, this line segment, and AB square. So let's forget about rest of it. What we'll do is, we will drop a perpendicular from here to obtain a right angle triangle because squares दिख रहे हैं तो आपका Pythagoras theorem लगेगा. So for Pythagoras theorem you require right angle triangle and the altitude of an equilateral triangle bisects the base, right? So keeping all that in mind, we will proceed this as we are saying consider an equilateral triangle. Let the sides of that triangle be A. That is for writing convenience. Every time using this, if we know equilateral triangle, all three sides are equal. So we have called each side of it of length A. So let us consider an equilateral triangle with side A. That means your AB, BC, AC. Any of the side is A each. Okay. And we'll drop a perpendicular or we'll make an altitude. Let AE be the altitude to obtain right angle triangles. Now, your BE is equal to EC is half of BC because in a right angle triangle, in an equilateral triangle, the altitude bisects the base. So BE is equal to EC will be half of whole BC. That is, it will be A by 2. Right? Now, if AE is equal to, this comes from Pythagoras theorem, children. You can apply in this big triangle if you want to find the length of this altitude, AE. Okay, so that will come as AB square minus BE square, right, by Pythagoras theorem. So that's A square minus A by 2 whole square. So that becomes A square minus A square by 4. Taking LCM, it will become 4A square minus A square upon 4, which becomes 3A square upon 4. Taking under root, A root 3 upon 2. Altitude, you can work it out yourself. If you can remember it, well and good. That will save your time. Otherwise, you can apply Pythagoras theorem to this triangle and find this altitude as A root 3 upon 2. Okay. Now, all that done, this was already given to us. BD was 1 by 3 of BC. That is, BC is the side, so we can write it as A upon 3. Okay. So, we've written all dimensions in terms of AAA. Then writing will be easy for us. Okay. So, but we had to talk about this right angle triangle in which we have side DE. So we are also working out this DE out here. So from the figure, this DE is BE, this whole BE minus BD. So BE was A upon 2 and BD was given to us as A upon 3. A upon 2 and A upon 3. So subtracting this, DE is coming out to be A upon 6. Take LCM here. 6. So 3 minus 2, that becomes A upon 6. Okay. Now we'll put that. Now we come to the triangles here. Triangle ADE. If I use this triangle, because AD हमें proof में लाना है, right? Okay. So by Pythagoras theorem, this hypotenuse AD square will be AE square plus DE square. Okay. So AE we have worked out was A root 3 upon 2, put that value. DE we have worked out here as a upon 6. Put that value as well. So this is coming as 3a square upon 4. This becomes a square upon 36. Next you take LCM. So 4 9s are 36. So 9 3s are 27. 27 plus 1, 28 a square upon 36. We'll cancel out by 4. 4 7s are 28. 4 9s are 36. So it's coming as, this is AD square. So AD square is finally coming as 7 upon 9 AB square. Cross multiplying, 9 AD square will come as 7 AB square. This is what we had to prove. Okay.